A very good morning to all of you, my dear students. We have started Laplace Transform. Already we have discussed regarding definition of Laplace Transform, advantages of Laplace Transform, shifting theorem, and differentiation theorem, Laplace Transform of different preliminary functions, right? Inverse of Laplace Transform, initial value theorem, and final value theorem. Today, I will explain transient analysis for RL and RC series circuit for different types of inputs like step input, impulse input, and sinusoidal inputs. Okay. Now, the presentation is visible?
Yes, ma'am.
Okay. So, transient analysis of electric circuits using Laplace transform. So, what is transient? An electrical engineering, a transient response or natural response is the electrical response of a system to a change from equilibrium, right? That is a change from the stable state, equilibrium state, that is transient. The condition prevailing in an electric circuit between two steady state conditions is known as the transient state. It stays for a very short period. The currents and voltages during the transient state are called the transients. In general, transient phenomena occur whenever a circuit is suddenly connected or disconnected to or from the supply. Okay, there is a sudden change in the applied voltage from one finite value to another. A circuit is short circuit. All these are conditions when the transient phenomena occurs. A simple example would be the output of a 5-volt DC power supply. When it is turned on, the transient response is from the time the switch is turned on and the output is a steady 5-volt. At this point, the power supply reaches its steady state response of a constant 5-volt. Now we come to transient analysis for RL series circuit for step input. Okay, already I think you are acquainted with the RL series circuit of transient. In lab and theory class, I think I have explained. Do you remember all these things?
Yes, ma'am.
Yes, ma'am.
So we come to Jamboard to explain it again. This is the Jamboard. The board is visible?
Yes, ma'am.
Okay. Again, I am writing the drawing the circuit R L series circuit. Okay. There will be a switch. Here will be a switch. The circuit is like this. VUT RL. UT means, do you remember VUT? It is step input. Or do you remember? VUT
Yes,
step
ma'am.
RL series circuit. Here is a switch. So if t equal to 0, it is the system is totally closed at t equal to time t equal to 0. The voltage across RL will be combination of mute for a. When I will ask anybody, he will unmute. Okay. The voltage across the RL combination would be Vt, which is a step of magnitude V or VUT, and not a constant as the supply voltage V. Already you know Vt equal to 0 for t less than equal to 0 equal to V for t greater than equal to 0. Many times I have explained it. Now what will be the differential equation here? RIT plus L didt, that is equal to VUT. Plain and simple, because across L the Drop will be L di dt, and across R it will be RIT. So applying KVL, this is the formula. Now if we take the Laplace transform in both sides, what will be the result? RIS plus LSIS minus I0 minus, this is the differentiation theorem, right? I think you remember that. VUT, here only variable is I. So this is constant. Any type of constant Laplace of that, what will be the answer? That constant divided by S, V by S here, right?
Yes, ma'am.
So RIS plus LSIS, that is equal to V by S. If I take the common IS into R plus IS, that is equal to V by S. Now IS equal to V by S into R plus LS, V by SL, R by L plus S, V by L, 1 by S into S plus R by L. And already you are acquainted with partial fraction, and this is the A by S and V by S plus R by L. If I do the partial fraction, what will happen? A will be Fs into S equal to 0. So if you put S equal to 0, you will get L by R, and here to get the value of B, the Fs into S plus R by L, put S equal to minus R by L, automatically you will get minus L by L. Now if you put the value of A and B, you will get Is equal to V by L into L by Rs, this is A, and minus L by R, the value of B, S plus R by L. Now if we take the inverse Laplace, what will happen? 1 by S is the Laplace of 1, right? Then what will be the inverse? That is the 1. And what will be the inverse of S plus R by L? It will be e to the power minus R by L into T. In the previous class, I have explained regarding inverse Laplace. Do you remember?
Yes, ma'am.
Then V by R, ultimately what is the current? IT equal to V by R, 1 minus e to the power minus R by L into T. Up to this, I think it is clear to all of you. Now we come to the transient part. From the equation, it is very clear. What is the transient part? V by R e to the power minus R by L into T. Now if you put T equal to 0, what will happen? E to the power 0 means 1, 1 minus 1 means 0. Then at T equal to 0, you are getting I equal to 0. Right? And
Yes,
if you put T equal to L by R, that is time constant, then it will give e to the power minus 1. E to the power minus 1 means 0.37. So you will get V by R into 1 minus 0.37, that is 0.63. After that, you will get ultimately 0.63 V by R, that is the steady state current. So what do you mean that here what is happening? When the switch is first closed, the voltage across the inductor will immediately jump to battery voltage. That is, it will behave just like an open circuit and decay down to 0 over time, eventually acting as through it was a short circuit. Voltage across is being dropped across R, given the current through the inductor, and subtracting that voltage value from the battery. When the switch is first closed, the current is 0. Then it increases over time until it is equal to the battery voltage divided by the series.
হ্যালো
আমার মনে হয় ম্যামে নেট গেছে।
ও আমি ভাবলাম আমার নেট গেল বলে।
আমিও তাই
এই
ভাবলাম।
থাম তোরা, রেকর্ডিং চলছে।
Hello, do you hear me?
Yes, ma'am.
Yes, ma'am.
It was not visible
Yes,
and
ma'am.
audible.
Yes,
Ma'am.
ma'am, you are audible. Yes, ma'am, audible.
Ma'am, you are not visible, but
I was audible or not?
yes,
No,
ma'am.
ma'am.
Yes,
You
ma'am.
are not audible or visible.
Up to which, I mean, I have explained a lot. I don't know from which time I was not audible. Can you tell me? Anybody can tell me?
Ma'am, where are you explaining that the current of resistance um, um,
ম্যাম
Some
একবার
first
প্রেজেন্টেশনটা
একবার
করুন, তাহলে হয়তো দেখে বুঝতে পারবো একবারে জায়গাটা।
when it presentation I am sharing. My God. It is visible. Presentation is visible.
yes ma'am,
Yes, ma'am.
ইয়েস ম্যাম। ম্যাম এগুলো আগে, আরো আগে।
হ্যাঁ এগুলো হয়ে গেছে ma'am।
এগুলো হয়ে গেছে ম্যাম, এই
Already I have
ইকুয়েশনের
covered
শেষ
all
থেকে, ইকুয়েশনের শেষ থেকে।
equation is
ইকুয়েশনের পর
covered.
থেকে ম্যাম।
হ্যাঁ, পর
হ্যাঁ,
থেকে
আর-
লিখুন।
হ্যাঁ, এই পাতাটা ম্যাম।
Okay, and I think now I am audible and visible both. It was a network
Yes,
issue.
Yes,
ma'am.
ma'am.
Sorry. This IT
Yes,
equal to
yes,
V by R 1 minus e to the power minus R by L into T. This is the current, right? Now we come to transient part of the current response. Obviously, the current response, the transient part is V by R e to the power minus R by L into T. That is time dependent part. And already you know I am audible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I am worried basically. T equal to tau, that is equal to capital L by R. At that time, capital L by R, if we put here capital L by R, what will happen? Root to the power minus 1. Then we will get 0.63 V by R, that is 0.63 IS, that is the steady state current. So, when the switch is first closed, what is happening? The voltage across the inductor will immediately jump to battery voltage, as if it was an open circuit, and decay down to 0 over time, eventually acting as through it was a short circuit. I am audible?
Yes, ma'am. You are audible.
Yes,
Yes,
ma'am.
Yes, ma'am. Yes, ma'am.
Now, voltage across the inductor is determined by calculating how much voltage is being dropped across R, given the current through the inductor and subtracting that voltage value from the battery. When the switch is first closed, the current is 0. Then it increases over time until it is equal to the battery voltage divided by the series resistance. Okay. This behavior precisely opposite that of the series resistor capacitor circuit, where current started at a maximum and capacitor voltage at 0. The steady state part of the current response, that is equal to V by R, the variation of the current, I will show it. The quantity tau equal to L by R is known as time constant. Everybody is acquainted with the time constant. Then what is time constant? It is the time taken for the current to reach the 63% of its final value, right? Thus, it is a measure of the rapidity with which the steady state is reached, right now. And also at t equal to 5 tau, I equal to 0.993 IS. I have explained it in the laboratory, right? Do you remember?
Yes, ma'am.
The transient is therefore said to be practically disappeared in 5 tau because it will be infinite. I mean saturated at the time t equal to 5 tau up to infinite. Now it will be better if we come to the Jamboard. So this is step response. It was step response. How many responses I have told? There are step response. There will be
Impulse.
impulse response. There will be sinusoidal response. We are dealing with right now step response. Ultimately, what I have got? What is the formula? I is equal to what?
V
V by R.
V by R ব্র্যাকেটের মধ্যে 1 minus
Yeah, 1 minus
e to the power
minus
minus
R by L
R by L.
into T.
Yes,
So what I have explained right now, if T equal to L by R, that is time constant, then what will happen? Anybody else? I equal to what?
I to 0.63 into IS.
How can you get it? Because if you put L by R, it will be e to the power minus 1, and e to the power minus 1 is 0.37. 1 by 0.37, that is
0.63.
Right. 0.63 V by R, that is the steady state value. You can depict it just like IS, right? Now, the question is that, okay, I'm coming to that question. Now, if you draw the graph, what will be the nature of the curve? This is T here, and along the y-axis, this will be IT. So if you put the time equal to 0, what will be the value? IT will be equal to what? IT will be equal to what?
0 ma'am.
0.
Right, I will be equal to 0. Okay, I am in the class. Okay, just a minute. Okay.